the topic I was treating was on simple harmonic motion. Okay, now let's solve the last question here before moving to circular and rotational motion. Okay, what you just have to do, you send the link on your platform for others to join. Okay, now some of you guys are a kind of will I say selfish. You just want to join only for your own self. Okay, just send to your friends so that they can also join. Okay, now let's solve this question here. Let's solve this question. The preparation is all about physics 101. Let's solve this, please. If y is equal to, okay, let me write the question up. If y is equal to 0.02, okay, sine into 30s minus 400t, or in meters, okay, let's say 15 over b pi over 15 meters, c 60 pi meters, d 30 over pi in meters. Okay, you can write, please. You say if y is equal to 0.02 sine into 30s minus 100t meters, that we should find the wavelength, and these are the options here. Please can write. Okay. Now, whenever I see a question like this, class, this on simple harmonic motion equation, okay? Whenever I see a question like this, all you have to do is to compare the given equation to the standard equation in terms of simple harmonic motion. So what is the standard equation relating to this simple harmonic motion here? It's going to be y is said to be equal to a sine, since the equation is sine, into omega t minus, since there's minus here, I put minus here, phi, please take note. So I will compare this, that is the given one, which is y is equal to 0.02 sine into 30x minus what? 400t. Okay. Now let's solve this. Comparing here, this is displacement. Please take note. This is displacement. This is amplitude, that is maximum displacement. So this is displacement, this will be amplitude. That means from this means that our A is going to be equal to 0.02 meters. Remember, they say all in meters. So this meter is only affecting the parameters outside, which is said to be this and this. Okay, anything inside here should be having the SI unit, except it's being given to us in the equation. Okay, now that means if definitely I have CM here, if I have CM here, that means this CM is only affecting only the parameters outside, which is said to be 0.02 and what? Y. Please take note. But we are giving only meters here. Okay, please don't be confused. Listen. If I have y equal to 0.02 sine into 30s minus 400t, if I have this, maybe I have a equation like this, CM like this. In case in any question, it means that this CM is outside, right? So it's only affecting the parameters outside, which is said to be only amplitude and what? Displacement, right? So anything inside that is not of outside should be what? In SI units. We said to be T should be in seconds, S should be in meter. Please take note. Except it's being stated that S is in cm. But this question here, the unit is said to be in meters here. That means at this point here, everything here, that is, this is meter, this should be in meter. If this is S, this should be in meter. Why this particular T here is what in seconds. Please take note. So under comparison, this is relating to this. That means our S equal to this. Okay. I can't compare sign here. Please take note of that because it's not related to any parameters in terms of wave. There's not like sign in terms of any wave parameters. Okay. Now relating this guy here to this, we say omega t is equal to this is the one having t here. Which of them having t here is 400t, right? Omega t is equal to 400t. Now divide both sides by t, so I can have omega. That means my omega will be equal to 400 rad per watt seconds. The unit of omega is said to be rad per seconds. So now let's compare which of them here, after comparing the one that has t here with this one. So this one here will be this. Please take note. So our phi, which is representing phase angle or phase shift, is said to be equal to plus 30s. Okay. Now from this, our parameters here, we can now solve what we are asked to solve. Okay. From these parameters here, A, omega, and phi, we can now solve what we are asked to solve. Okay. So this is the first thing you have to do before you calculate what you are asked to calculate. All right. Okay. Now let's calculate the wavelength. We are asked to calculate wavelength, and we use lambda as our wavelength. Please take note. So now let's calculate the wavelength here. But before we calculate wavelength here, we have to ask ourselves this question: which of the parameters here that is connecting with wavelength? Which of the parameters here, either this or this or this? Which of them here that is connecting with wavelength? Of course, this omega here is connected with angular frequency or period. Please take note. While amplitude is connected with maximum velocity. If you're asked to find maximum velocity, which is said to be maximum velocity A mass is equal to omega A. Please remember. Okay. Now that means if I'm looking for maximum velocity, the formula is said to be omega A. Where this is said to be angular velocity, this is said to be what? Amplitude. Okay. Now if I'm looking for that is said to this frequency, which is said to be omega, is equal to pi f. Please take note. While this guy here is related to wavelength, which is said to be phi is equal to 2 pi over what of s over what lambda. So between this, and this formula, which of them related to lambda is what? Phase angle or phase shift. That means using phi equal to 2 pi s over lambda here, and now solve for our what? Wavelength. Please take note. So now let's replace. This will be 30s is equal to 2 pi s over what? Lambda. My intention here is to make lambda the subject. Now listen, this descendants over 1 here. In mathematics, if I have this to be 2 like this, is descendants 2 over 1. Please take note. If I want to write 2 in terms of fraction, is descendants 2 over 1. Okay. Now I can also write this guy here. That is, I can also write this 30s as 30s over 1. Please take note. So in mathematics, if I have division at the right and division at the left here, I can cross multiply. When you do that, our lambda will be equal to 2 pi s over what? 30s. So this can cancel this. Please take note. So now let's try to solve this. This go here is 1. This go here is 15. That means my answer is going to be pi over what? 15 meters. So the answer is said to be pi over what? 15 meters. Okay. Now this is maybe the hardest question as far as SHM equation is said to be concerned. Okay. From the one we have solved, from the first one, this second one, you can solve anything about simple harmonic motion equation. Please take note. Okay. Now let's solve some question on circular motion and rotational motion. Okay. The next topic, please. Okay, the next topic is that is circular motion and rotational motion. All right, now this class we unveil everything about circular motion and also everything about what rotational motion. Please take note. And each of them I'm going to solve one question each. And but before them, I will unveil everything that you have to know about circular motion and everything you have to know, and some shortcuts you have to know about rotational motion. Okay. Now let's start with circular motion here. Please write circular motion. Circular motion. Circular motion can be defined as a motion in a circle or circular path. A motion in a circle or circular path. Please take note. Circular motion can be defined as a motion in a circle or circular path. Okay? Now, when we are speaking about circular motion here, there are some formulas related to circular motion we have to know. Formulas, please write something. Formulas related to circular motion. Formulas related to circular motion. Number one, we have centripetal force. That is FC. Please take note. Centripetal force. Now let's define centripetal force here to know more about it. Centripetal force can be defined as force towards the center. Force towards the center. Okay? Centripetal force can be defined as force towards the center. Mathematically, FC here is equal to mv squared over what? R. Please take note. Now, this is the formula relating to centripetal force. M represents mass, V represents speed or velocity. Please take note. Sometimes speed and velocity are the same. Please take note. R represents radius. Radius. Please take note. Okay. The next is said to be centripetal acceleration. Which is said to be AC. The next is said to be centripetal acceleration, AC. And they can be defined as, let's take a definition here. Centripetal acceleration can be defined as, acceleration towards the center, okay? Now, it can be denoted by AC. So mathematically, AC will be equal to class. We can know the formula without even stressing ourselves here. Compare the formula for centripetal force to linear force formula. That is F equal to MA. Let's compare. This is force, this is force. This is mass, this is mass. So anything taken after, any parameter after mass here in this formula should be what? Acceleration. That means our acceleration is going to be V squared over what? R. That is mathematically here, AC is going to be equal to V squared over what? This class R. Please take note. Now we call this formula centripetal acceleration. Now the next one here, let's consider the next formula here. The next one is said to be linear velocity or linear speed. Linear velocity or linear speed. Okay? Please write. Linear speed or velocity can be defined as the product of linear speed, or velocity can be defined as the product of angular velocity and radius. The product of angular velocity and radius, we use V to represent that, which is equal to W times what? R. That is the product of angular velocity and radius, which is this one here. So this is said to be angular velocity here. Why do we call omega angular velocity here? Because we are comparing this omega with what? Velocity. Okay. Why this arrow here represents radius. Please take note of this. Okay. Now the next one here is said to be, listen please. Note this, that this linear velocity is the same thing as tangential velocity. Please take note. This linear velocity here is the same as tangential velocity. Isn't everybody idea? Isn't everybody idea? How many persons there? No, it's me. Okay. Well, let me. Now, this can also be called tangential velocity. Please take note of that. Okay. We can also call this tangential velocity. Okay. Now, let's solve some questions here. If there's any question, let's solve some question here. Example 1. Are you done? Okay.
No, it's not.
Somebody say it was a vector.
Okay. Just type this. Just type that. We'll do that one.
No, it's from the live comment.
Okay. Can I go?
Yes.
Okay. Let's continue, please. Let's have a question here. All topic will be treated, okay? All topic will be treated. Just calm down. All topic will be treated. Okay, let's take a question here. As a stunt pilot, as a stunt pilot, example 1 here. As a stunt pilot flies a circular path, as a stunt pilot flies a circular path. In bracket, you write radius equal to 0.40 kilometer. In bracket, you write radius 0.40 kilometer, which lies in vertical plane as a stunt pilot flies a circular path. In bracket, you write radius equal to 0.40 kilometer, which lies in vertical plane. He maintains a constant speed of 250 kilometer per hour. He maintains a constant speed of 250 kilometer per hour. Full stop there. Determine the magnitude of the acceleration. Determine the magnitude of the acceleration of the pilot. Determine the magnitude of the acceleration of the pilot. A, 7.6 meter per second squared. B, 2.3 meter per second squared. C, we have 6.3 meter per second squared. D, we have 12 meter per second square. Okay. Now these are the options here. Now, we all know that when we have when we have a particular question in a circle, and we are asked to find the acceleration in that circle, at that point, it's said to be what? Centripetal acceleration. Please take note. So these are the parameters given to us here. That is, radius is given to us as 0.40 kg, while the velocity given to us as 250 kilometers per hour. Okay. Now, at this point here, please take note of this. At this point here, I have to convert, since they are not given to us in SI units, I have to convert this radius here to meter. Please take note. So that means our radius here is said to be 0.40 kilometer. So converting to meter, this kilo here is a prefix in mathematics. And this prefix here has a numerical value, that is a value. Please take note. We have kilo is said to be 10 raised to the power of 3. Please take note. We have milli is said to be 10 raised to the power of minus 3. Please take note of these prefixes here. We have micro is said to be 10 raised to the power of what? Minus 6. We have what again? Nano is said to be 10 raised to the power of what? Minus 9. Please take note. We have pico. So this 10 raised to the power of what? Minus 12. Please take note. So these are the prefixes you need to know. Okay. If they say kilo, just replace that to be just like if I have 2s here, and they say s is equal to 4. What does it mean? Anywhere I see s, it replaces for this class 4. So the same thing here. So anywhere I see this particular word or this stuff here, this prefix here, kilo, I replace this to be what? 1,000. Please take note. So replacing this guy here to be 1,000, that means I'll be left with meter. So this will be 0.40. Replace 1,000, that is 1, 2, sorry, please take note, okay? In what? In meter. This will be something like this. Okay, so that means I'm passing by 1,000. That means this will go off. Please take note of that. Okay, so the next one here is said to be our velocity or speed. Is given to us as 250 kilometer per hour. Okay, now please take note of this, that this 10 raised to the power of 3 here does not mean that I should add it here. Please take note. Since there is point here, it means I should times it by what? 1,000. So times 0.40 with 1,000, you are going to get a result there. Please take note of that. Okay. Now let's convert this guy here. Converting this guy from kilometer per hour to meter per second, because in physics we always use our SI unit. That means our length should be in meter, our mass should be in what? Kg, our time should be in what? In seconds. So converting these guys here to SI unit, we have this to be 250 times this 1,000. I will have this in meter over 3600. We know that that 1 hour is equal to 60 times 60 in seconds. Please take note. So I'm going to have 3600. Please take note. In what? In seconds. So now let's punch our calculator, please. Okay, let's punch our calculator. Now punching your calculator, okay, let's punch our calculator here. Is it recording that one? Is it there? Where is my calculator? Okay, now let's punch our calculator. When you punch your calculator here, you have, this is 1, 2, this will be off. This will be 4, 0 in what? In meters. Okay, you punch your calculator. So this one will take it out. It will remain only 10 raised to the power of 2, which is said to be 100. So 4 times 100 is going to give us this guy. Then now let's get this one here. So 250 times 1,000 Let's get the answer. Divide by this. I mean, yes, what's the answer? 69.4, like this, meter per second, right? Okay, everything right? Okay. That means you have converted here. The next thing here is to calculate the circular acceleration. Consider circular acceleration A is said to be centripetal acceleration, which is said to be V squared over what? Please take note. Now, replacing our V, we have this to be 69.4 all squared over what? Our radius is what? 400. You can write, please. So we have this to be 69.4 all squared divide by 400. Okay. Now put your calculator. 69.4 all squared divided by 400. What will be the answer, please? Yes, we can make this. No, my this thing is use here, please. Now let's get the answer, please. That is 69.4 all squared divided by 400. What will be the answer, please? Okay. 12.04. Everything. That is 12.04. Are you sure? Now get this one first. 250 times 1000 divided by 3600. Confirm. Yes. Yeah, this one. But this one gave us divided by this. Okay, is there any option like that? Okay, there's an option, right? So D, Abi. Okay, that means we have this to be in meter per second square. Okay, please take note. And let's solve the next question here. That means we can calculate anything about centripetal force and centripetal acceleration. Okay, what you just have to do here is to understand this. That whenever you are solving any force in a circle, is going to be centripetal force. Whenever you are solving any acceleration in a circle, it's going to be centripetal what? Acceleration. Okay, please take note of that. Okay, now let's move into rotational motion here. Okay, let's move into rotational motion here. But before we move into rotational motion here, we have to know the analogy between linear motion and circular motion. Please write analogy between, okay, can I clear here? Analogy between linear motion and rotational motion. Okay, analogy between linear motion and rotational motion. Okay. Now remember, when I'm comparing the linear motion and rotational motion, I'm also comparing circular motion also. You see the same? Okay. Just that the difference between rotational motion and circular motion is that in rotational motion, there's a fixed point, while in a circular motion, there's no fixed point. Please take note. Okay. Now let's write analogy between linear motion and rotational motion. Analogy between linear motion and rotational motion. Okay. Now let's try to know the analogy here. From here, we can now know the formulas in terms of using what we know, which is linear, and get what we don't know. Okay. Using what we know to get what we don't know. Okay. Now let's try to get the relationship. This is for linear motion. This is for rotational motion. Okay. In linear motion here, we call it velocity. That is, we use V or U to represent this. While in rotational motion here, class, we call it angular velocity, and we use omega or omega naught. Please take note. So in linear motion, we call it distance, which we use S or S. Please take note. Now in rotational motion, we call it angular distance, and we use theta to denote that. In we call it acceleration, we use A to represent angular acceleration, and we use alpha to represent this. Please take note of this. Okay. Now the next thing here is said to be mass. We use capital letter M to represent mass, but here I'll call it moment of inertia, and we use I to represent this. Please take note. Now the next one here is force. We use F to be F equal to MA, but here we say that it's what? Torque. We call it torque, and we use tau to represent this. Now the same formula, what do we take as our mass? We take what? I. That's moment of inertia. That's I. What do we take as our acceleration on this page here, on this stage here? We take what? Alpha, which is this alpha here. Okay. The next one here is kinetic energy. Kinetic energy. And it's said to be KE. We use 1/2 mv squared. But here we'll call it rotational kinetic energy. Rotational kinetic energy. And we use KE rod. This is the 1/2. 1/2 is constant, it's a constant value here. So what do we take as our M here? Our M is what? I. Please take note. Now what do we take as our V here? Our V here, which is final velocity, is what? Omega, which is omega squared. Okay, please take note. Okay. Now from what I told you guys, if I want to express power, that is power, which is said to be force times velocity here. Remember, power can also be force times velocity when you are comparing with force. Comparing with force, when you are giving velocity to calculate power, you can use this formula here. Now, if power to be force times velocity here, what would be our rotational power? Please, from what I told you guys, what is our F? Our F is torque, all right? That is torque times what is our V, which is velocity, right? We will call it angular velocity in terms of rotational. That is angular velocity. That means power will be torque times what? Omega. Please take note in case you have something like this. So that means from this, we can use this now to form any formula relating to rotational motion, from what you know to what you don't know. Okay. Now the next thing here is to form an equation. Please take note. Just write equation of circular motion. Subheading equation of circular motion. Okay, but just write them, please. Just write them, please. Just write them. Okay, please share on your WhatsApp platform, except you want us to end the class. Yes. If I'm seeing only 9 persons there. I'm seeing only 9% or 11%. So if I'm seeing only 11% there, I'll just end the class because there's no need. You get? So share on your WhatsApp platform. Okay? Share on your WhatsApp platform. You can just write them, please. Just write them. Okay? Okay. Okay, please share. I'm still waiting so that I can get up to 20 before that. Okay, share on your platform. Please, you can just write. I'm seeing 13. I want to see 20 something. I want to see 200. Share on your WhatsApp platform. Don't be stingy. Okay. But let's continue, please. For those that are not hitting the button, try and hit subscribe button. Okay. Try and hit the subscribe button. There's some complaint that is network issue. Okay, no problem. Now let's continue, please. Please write equation of circular motion. But just put down this, that whenever you see angular velocity, we use this omega here. Please take note. Okay. Now, whenever we see angular distance, we use this one here. Whenever we see angular acceleration, is this one here. Okay. Now, please write equation of circular motion. Equation of circular motion. We'll solve the equation there. Please write equation of circular motion. Okay. The first one I treated was on formulas relating to motion, but this is equation of circular motion. Now, from what you know, listen please, from what you know about equation of motion in a linear form, we say that V is equal to U plus AT, right? The next one is V is equal to U squared plus what? 2AS. The next one is S is equal to UT plus half AT squared. The next one is S is equal to V plus U over what? 2 times what? T. Please take note. Now, from what we know here, we want to change this to circular motion here. Remember, in terms of circular motion, we use omega as our final velocity, which is said to be omega will be equal to, we use omega naught to represent our initial velocity here. This is said to be omega naught plus, we use alpha to represent our acceleration here, that is alpha t. This is our first equation of circular motion. Now let's do the same thing here to change from here to circular motion equation. So this is going to be omega squared is equal to omega square naught, that is this one here, please take note, plus 2 alpha. Now this, we use theta to represent the angular distance, that is theta. This is my equation 2, please take note. Now the next one here is going to be theta will be equal to plus omega naught t plus 1 over 2 alpha t squared. This is our equation 3. The last one here is said to be theta is equal to plus omega naught plus, omega plus omega naught over what? 2 all times what? Okay. So this is circular motion. Now we can apply them. Please take note. The one we know to form this guy here. Okay. You can just write them down. Okay, you can just write them down. That is omega. This is final angular velocity. This is initial angular velocity. is angular acceleration. This is time. Time remains the same. Please take note. Okay. Now the same thing here. Okay. Now theta is said to be the what? Angular distance. Okay. Now please just write before we solve the question here. Just write before we solve the question here. Okay. Question here, class. Example 1. Let's solve a question here. Example 1. That is question 1. Okay. Okay, let's example 1, please. What is the angular acceleration? What is the angular acceleration of the motor of a grinding wheel? Of the motor of a grinding wheel. Okay, let me repeat myself again. What is the angular acceleration of the motor of a grinding wheel if it rotates at 60 rev per second? If it rotates at 60 rev per second for 80 seconds. For 80 seconds. Okay. Now let's take the options here. Let's take the options here. A. Please write down the options. A, 1.5 pi rad per second. B, 7.5 pi rad per second. C, 0.75 pi rad per second square. Please put square here. I'm sorry. D, 15 pi rad per second square. Please take note. Okay. Now let's, in solving any question in physics, we first of all understand the equation before we solve. Now since the pi here, since there is pi in the option here, it means that they did not replace pi as 3.142. Please take note. That means whenever we are solving for pi, whenever we are solving and there is involvement of pi, we're not going to replace that as 3.142. Please take note. Okay. Now let's understand the question here. They said, what is the angular acceleration? That means they are looking for the angular acceleration. Please take note. So we are looking for, this is angular acceleration. It's not given to us here. Now, what are the things given to us here? They said the rev per second. Remember, the unit of angular velocity is said to be rad per seconds, but it might also be given to us in terms of rev per minute. Please take note, or rev per seconds. So these are the units that might be given to you in terms of angular velocity. Now, the standard unit is rad per seconds. But sometimes they might give you rev per minute to change to rad per seconds, or rev per seconds to change to rad per seconds, okay? Depending on the one given to you here, okay? Now, in this question here, we are giving omega to be 60 ref per second. That means anything given to us in terms of rad per second is said to be omega. Either anything given to us to be ref per minute is said to be omega, or anything given to us in terms of ref per second is said to be omega. But in using that particular parameter, we always focus on the main SI, which is what? Rad per second. So if you are giving omega as ref per minute, you must convert to what? Rad per second. If you are giving omega in ref per second, you must convert to rad per second before you solve. Just like if I'm giving length to be 10 cm here, I have to convert this guy here to be what? In meter before I solve. Please take note, okay? Now, doing that, the next thing given to us here, they said that it rotates in t equal to 80 seconds. That is time is given to us here. So before I solve this question here, I have to understand the question carefully and I listed out the given parameters. They said to be this and this. But before the object rotates, what happened? It must be at rest, just like your slim fan, okay? So if an object is at rest, that means omega naught will be equal to class 0. Please take note. Whenever an object is at rest, our omega, that is the initial velocity, will be equal to 0. Please take note of this in terms of motion. Whenever an object starts from rest, the initial velocity will be equal to 0. Whenever an object stops or moves, whenever an object stops, it means that v is equal to 0. Please take note. Whenever an object is starting from rest, u is equal to 0. Whenever an object is starting from rest, u is equal to 0. Whenever an object stops or decelerates, v is equal to 0. Whenever an object stops or decelerates, v is equal to 0. Whenever an object moves in a constant velocity, a is equal to 0. So relating this guy here in terms of circular motion, that means whenever an object is at rest, omega naught is equal to 0. Whenever an object stops or decelerates, omega is equal to 0. Whenever an object moves in a constant velocity, that means alpha will be equal to 0. Please take note, okay? Now, these are the parameters here, okay? So at this point here, we say that before an object rotates, it must be at rest. That means omega naught is equal to 0. Please take note. So solving this, in solving any equation of motion, we first of all compare the given parameters and the parameter we are asked to calculate. Please take note. So now let's go into here. Omega is given to us here, that is this. And omega naught is given to us here, that is this. Alpha, we're looking for alpha, and t is given to us here. So the complete equation to use is this. But before we solve this, I told you guys that we have to convert this guy from 60 ref per second to what? Rad per second. So how do we convert from ref per second to rad per second here? Of course, if I have this to be 60 ref per seconds, it's still the same thing to write this to be 60 times 1 ref over seconds, like this. If it's measured in meter here, that's minutes, like this. That means converting from minutes to seconds is going to be 60 seconds. In case, please take note. But at this point here, it's already given to us in seconds. That means there's no conversion here. We repeat our seconds here. Please take note. Why? Now, class, if I have this to be 2s like this, remember that this is the same thing as 2 times 1s. But we don't have 1s in terms of mathematics. So this can also be written as 60 times 1 ref over seconds. So now let's know the relationship between ref. Please take note. Let's know the relationship between ref and radian. We said that 1 ref, that's 1 revolution, 1 circle, in terms of angle, is said to be 360 degrees. Please pay much attention here. That 1 revolution is equal to 360 degrees. That means for 1 revolution, is said to, in degree, is said to be 360. Please take note. So the same thing here, that 1 ref in terms of radian is said to be equal to 2 pi rad. Please take note of this. So that means relating these two guys here, I have this to be, relating these two guys, degree and radian, is going to be, please take note of that, that is 360 degree. Anywhere I see 1 ref, I replace to be 360 is equal to 2 pi rad. Please take note. So class, we can reduce this since 2 is common here, 2 is common here. That means our pi here in radian is equal to 180 degree. Please take note. So our pi in radian is equal to 180 degree. So, but these are the points you have to know from this conversion, that 1 ref is equal to 360 degree. That is 1 revolution is equal to 360 degree. Now, relating that ref in terms of radian, 1 ref is equal to 2 pi radian. Please take note of this. Now, relating radian in terms of we are sorry because of the network, okay? Now, let's continue. Let's continue. See, it's data. I've recharged. Yes, it's not coming up. Come, it's not. I've recharged. Don't worry, it's not. Don't worry, it's coming up. Check. It's coming up. No? Okay. We are sorry for this. You can just copy, please. Now, for it to look like what you have in the option there, you can just say 3 divided by 2 give us 1.5 pi rad per second square. So we can just take the option there. Please take note. Okay. Now, this is how we solve any equation of circular, any equation of circular motion. Please take note. So now let's try to treat more on the rotational motion, but just copy, please. Okay. Let me clean this. Why the color?
That image perfectly.
And we have even completed a particular topic.